Good afternoon, class. We are looking at inverse trigonometric functions. Part 2. We looked at all trigonometric functions and their inverse, and now we are going to look at cotangent. Again, just like any other trigonometric function, cotangent is also a periodic function, therefore it's not one-to-one. So in order to make it so, we are going to restrict it to make it one-to-one. Remember, y equals cotangent x. X goes from negative to positive infinity. X can't be n pi. Those are the vertical asymptotes. And y is from negative to positive infinity. So they're going to restrict it simply from 0 to pi. And now it's a one-to-one function. Now its inverse looks like that. All you have to do is just pick up a few pairs like this one. This one is pi over 4, for example. One. And as you can see, the vertical asymptotes for one cycle, x equals 0, x equals pi, now becomes horizontal asymptotes, y equals 0, y equals pi. And this point has coordinates pi over 2, 0. This one has coordinates 0, pi over 2. So it's easy to see the graph and how it works. We want to find cotangent inverse of 1. We let it be theta. By definition, when y equals cotangent inverse x, x is cotangent y, therefore cotangent of theta must be 1, which is a common arc, and we know it to be pi over 4. Secant inverse of 3. We know secant is 1 over cosine, and by the way, we're going to use a calculator because it's not a common arc. So secant equals 3 is the same as cosine equals 1/3. So cosine inverse of 1/3. And if you use a calculator, cosine inverse of 1/3 is 1.23, and it continues indefinitely. That's 1.23 radians. Cosecant inverse of -4. Sine equals 1 over cosecant. So the reciprocal of this number is sine inverse. Again, the relationship between secant and cosine, the relationship between cosine and sine. And so again, it's not a common arc. You put it into a calculator and it gives you -0.25, and it continues. So you can say -0.25 because they're asking for 2 decimals. -0.25 radians. By the way, if you ever come up with a negative value and you want to go from 0 to 2 pi to make it positive, you add two pi. That's all you have to do to make this positive. Or multiples of 2 pi, because if for any reason you add 2 pi, and of course in this case it has to, but in some cases if it doesn't, because it's an inverse function, then you can add multiples of 2 pi. Cotangent inverse of 1/2. Now calculators have sine inverse, cosine inverse and tan inverse. That's why we used cosine inverse here, we used sine inverse here, okay? So what happens with the cotangent? It's very important to see why we're going to go to cosine, and then I'm going to discuss the tangents in a moment. To go with the cosine, remember cotangent is x over y. So if you take this to be x, this to be y, then x squared plus y squared equals 5, and r becomes 5, okay? So P has coordinates 1, comma 2. X squared plus y squared is 5 because 1 squared is 1, 2 squared is 4 is 5. And therefore, you can use cosine inverse of 1 over square root of 5 because you are going to use a calculator. That's why it's not a common arc. And so if you put it into a calculator, cosine inverse of 1 over, this is 5 to the power of 0.5, square root of 5 gives you this answer. Now, if cotangent inverse is given, and if if this number is positive, you can use tan inverse of 1 over x. So if I use tan inverse of 2, I will get to the same answer. Now you might ask, okay, why did we go to cosine and not necessarily sine? In this case, makes no difference. But in this case, it does. And here's the reason. The restriction on tangent is like sine, from negative power to power 2. Of course, the endpoints are not included. For cosine and cotangent are the same. 0 to pi, in this case 0 to pi, the endpoints are included. That's why if you go to cosine, if you can find the value for cosine, it gives you the exact answer regardless. If it's negative, you use negative. If it's positive, you use positive. What happens if you want to use tangent? I'm going to explain that in a moment. So first and foremost, this is negative 2. And we're talking about 0 to pi, which puts us in the second quadrant where x is negative. So cotangent is negative 2 over 1. So it makes x negative 2, y 1. And when you square negative 2, you get 4, 1, you get 1, you add them up, you get 5, and it's square root of 5. So I just wanted to make sure we understand how we arrive at it. And cosine, so if you want to get to that, you can find cosine inverse of x, which is negative 2 over r, which is square root of 5. You can use that. So calculator will give you the exact answer, of course, in radians, and you're fine. However, whenever this is negative, if you want to use tan inverse, you can write the reciprocal, which makes it 1 over negative 2 or negative 1/2. And then you must add a pi. Here's the reason you have to add a pi, because tan happens from negative power 2 to pi over 2, tan inverse. Okay, so you have to go to the second quadrant by adding pi. And if you notice, this number is the same as this number, but not this one. So again, whenever the number is negative, if you use the tan inverse, it doesn't give you the answer. You must add pi. Why is that? The restriction on tangent is different than the restriction on cotangent. Okay, tan goes from negative pi over 2 to pi over 2. And so you have this and this to be identical if you use it properly. I wanted to spend enough time on that to make sure that makes sense to you. Now, write a trigonometric expression as an algebraic expression. What I have here, I'm reminding you of what's happening in various quadrants. So it's good to be aware of that. In the first quadrant, everything is positive. In the second quadrant, sine is positive. With sine goes cosecant. In the third one, tangent is positive and therefore goes cotangent. In the fourth one, cosine is positive, fourth quadrant, and therefore secant must be also positive. So we are going to let this one be something like an angle or arc theta. Therefore, we are looking for tan of theta given u, what is sine of theta. So please understand, if you let this one be theta, that means tan theta is u. That means what is sine theta when tan theta is given. So we can find some sort of relationship. And to do that, we can go with the circle or we can go with identities. There are different methods. So for example, 1 plus cotangent squared equals cosecant squared is one of those identities, Pythagorean identities. And cotangent is 1 over tan and cosecant is 1 over sine. And that's how you relate these two. So the left side, if you take a common denominator of tan squared, you get tan squared plus 1 over tan squared. Here's the left side. The right side doesn't change. If we do the cross product, okay. So sine squared, if I do the reciprocal, 1 over sine squared is that. Sine squared over 1 is the reciprocal of this, tan squared over 1 plus tan squared. So again, reciprocal of this, reciprocal of that. And therefore, we are going to use u here. We get u squared over 1 plus u squared. Sine would be the square root of that plus minus. However, we can drop the minus because sine and tangent have the same sign, because both of them are defined from negative power 2 to power 2, the fourth and the first quadrant. The difference is sign has the equality as well. That's why they become equal. I will look at the second method. So we said if theta represents tan inverse, and we should know all of this, you know. Okay. So sine of tan inverse of u means sine theta. That's the meaning of it. Again, this is a slightly different approach. We want to find a relationship between the two. If we multiply this by cosine over cosine, because cosine over cosine equals 1, nothing changes. Nothing changes. This is the same, right? Cosine over cosine is 1. So if we put the cosine underneath sine, we can do that. We get tangent theta times cosine theta. And we know cosine theta is the same as 1 over secant theta. So we can write it as tan theta over secant theta. That's one way of writing it. On the one hand. On the other hand, we know the relationship between secant and tan is that 1 plus tan squared is secant squared. So we can replace the secant with the square root of that. By the way, we know secant is positive in the first quadrant and the fourth quadrant. Why is that? Because cosine is positive. Cosine is positive, so is secant. That's why we don't use plus minus, we just use the plus. All right, so far so good. Replace the tan theta with u, and you have the answer. So different methodologies. I just wanted you to be familiar with different methods. Write a trigonometric expression as an algebraic expression, tan of sine inverse of u. It's similar to the previous one, which was sine tan inverse of u. It's sort of similar. So first of all, this is an arc. Let's say it's theta. By definition, and again, we have all those properties. By definition, sine theta becomes u, and we are looking for tan theta. Given sine, find tan. So we look for one of the identities that will work for us, and we know that tan theta is sine over cosine. So we have the sine, and we can go from sine to cosine easily. We remember sine squared plus cosine squared equals 1. We should remember that. We should know. And therefore, cosine is plus minus the square root of 1 minus sine squared. Okay. But the reason it's positive, because, again, cosine is positive in the first and fourth quadrant. Remember, sine is in this vicinity, and that's where cosine is positive. And you change the sign to u, and again in quadrant 1 and 4, sine and tan have the same sign. That's another way of approaching it. Or in those quadrants, cosine is positive. Also, cosine is positive. All right, how about this one? We're going to let this one be theta. And of course, remember, secant is between 0 and pi. Theta can be pi over 2. And so if you do that, you're looking for tan of theta. So theta is secant inverse, u is secant theta. We are looking for tan theta, and it goes from 0 to pi because secant has the same restriction as the cosine. So we know 1 plus tan squared is secant squared, which makes tan squared secant squared minus 1. And it makes it plus minus square root of u squared minus 1. So in other words, replace the secant with u, everybody. In quadrant 1, tangent is positive. In quadrant 2, remember, this is quadrant 1 and 2, right? From 0 to pi. In quadrant 2, tangent is negative. That's why we have both signs. So one more time. You don't have both signs. Cosine is positive, or you can say sine and tangent have the same sign. But in this case, since this is from 0 to pi, tangent can be either positive or negative. We don't know that. We need to know which quadrant to know exactly which one. Cosine of sine inverse of u, again, we are going to work on that. Sine inverse of u, that means if we call it theta, sine of theta is u. We want cosine theta, and of course, sine is between negative power 2 and power 2. And so sine of theta is u, class from here. Sine theta is equals u. Okay. And so we want cosine theta. We want cosine theta. If sine is given, what is cosine? Sine squared plus cosine squared equals 1. It's a very common identity we should be very comfortable with. So cosine is plus minus the square root of 1 minus u squared. However, why are we using plus only? Again, please understand it's plus minus, and then we choose the positive. Because in the first and the fourth quadrant, cosine is positive. That's why.